to Hong Kong now, and 30 people have died, or Japan have died after a series of powerful earthquakes struck Japan yesterday. A major tsunami hit the coastal area of Noto, with nearly 100,000 people being asked to evacuate.
Well, joining us now is Professor of Earthquake Engineering at the University of Bristol, Professor Anastasios Sextos. Very good morning to you, Professor. Please just let us know. Good morning. Is the threat of this, of a serious tsunami, has it passed? Because I know it was downgraded yesterday. And is the big concern now, I suppose, all these people who've been evacuated in very low temperatures to high ground, which is actually in itself a bit of a crisis? Or is there still a risk of a tsunami all this time on from the earthquake?
That's a very good question, actually. The early warning that relates to tsunami is not a prediction ahead of future events. It's the consequence of an earthquake that is happening, and then there is a message that the tsunami is coming. So for the earthquakes that have already taken place, that's the major event of 7.5 or 7.6, depending how you measure it, yesterday's event, the risk is gone because the waves have faded out and there is no chance that there will be a tsunami out of this previous event. Now, if or in any chance there is a future earthquake that is strong enough to trigger the risk of tsunami, a new warning will be issued.
How come that the country has escaped so many fatalities on this one? We've seen other countries where weaker earthquakes have hit and they've produced more fatalities.
That's true. The reason is twofold, in my opinion. One is obviously preparedness. Japan has long tradition not only in developing earthquake engineering technologies or the culture of protection, but also is learning from previous events. After the 1995 event, the whole culture of how we design worldwide actually has been revisited. The seismic codes have been updated. After the 2011 event that triggered a very large tsunami, if you may recall, again, large seawalls were created, early warning systems were developed, and recovery plans were put in place. So preparedness is definitely one. But in fairness, this is an earthquake that has also some specific features. For example, the large dual earthquake in Turkey this year was onshore, and it was back to back within 8 hours. Very strong earthquakes, pretty much of the same intensity. Whereas this one is offshore, and not only offshore, but it's on the west side of the Japanese coast, which is, let's say, less populated. So the exposure of buildings, of people, is relatively less. Therefore, I think these are the two main factors that have reduced, hopefully, to this reduced loss.
Okay. Professor, you're a theorist in all of this. You're an academic studying all of this. Have you ever personally experienced an earthquake?
Well, yes, probably that was the reason that we ended up in this kind of scientific field. I've been grown up in Thessaloniki, in Greece. Greece, like all Southern Europe, like Latin America, like Japan, Taiwan, these are seismic regions. And we experienced a strong earthquake, not as large, but had significant fatalities. I still remember actually living in a tent for about a month. So I know what it means to recover quickly, how it means to be resilient as a community, how it means later on to learn from earthquakes, because this is a stochastic, this is a random problem. You cannot predict it short term. You need to understand it and build infrastructure that is able to resist and build resilience to the community and agents to be able to cope with it. So we're still learning, I think, after so many years. Still a student in this regard.
Fascinating. Thank you.
Professor Anastasios Sextos there. He's a professor of earthquake engineering at the University of Bristol.